Hi everyone, my name is Idoy Rani and I'm a PhD student at the Weizmann Institute of Science in Israel under the supervision of Professor Avishai Galiam. I'm happy to share a paper that I've recently published on behalf of the ZTF collaboration about a very unique supernova. But first, let me give you some background. The ZTF survey is making a movie of the night sky in order to study transient astronomical phenomena such as supernovae. When a supernova explodes, it ejects material with velocities of up to 10,000 kilometers per second. Within one day, this ejecta will have expanded out to 1 billion kilometers, or a bit more than the orbit of Jupiter, sweeping up any material that was scattered close to the progenitor star. As our surveys become better and better with better time resolution, we can catch supernovae closer to the time of their explosion and see them interact with this close bound circumstellar material. The better our time resolution, the closer we can catch it to explosion, the closer the circumstellar material will be, and the better handle we'll have on it. Since some of this material is also moving outwards, but with a lower velocity, we know that it was ejected from the progenitor not long before the explosion, weeks or months. This helps us study the mass loss history of stars in the very final moments before they explode. In our paper, we report the discovery of 2022 OQM. This supernova is a type 1c supernovae, typically arising from a stripped massive star undergoing core collapse. We detected this supernova only a few hours after explosion, with the first spectrum taken at an age of 0.6 days. During the first 3 days, the spectrum of 2022 OQM is dominated by high ionization carbon and oxygen features, with a velocity of about 4,000 kilometers per second, which we associate with slower moving circumstellar material. This is then overtaken by broader features, indicating the higher velocity ejecta has reached the circumstellar material and overtook it, accelerating it to even higher velocities. While 4,000 kilometers per second is slower than the ejecta velocity, it's very fast for circumstellar material, which is typically slower than 1,000 kilometers per second. This would make this one of the only cases where circumstellar material this fast has been detected. During the first 3 days, the supernova shines strongly in the UV and optical wavelengths. It rises and declines very quickly. After about 3 days, this evolution slows significantly, and the light curve slowly rises to a second peak over a 15-day timescale. We believe that the behavior in the first 3 days is related to the interaction of the ejecta with the circumstellar material, as evidenced by the spectrum. To add to the mystery of this supernova, the spectrum at late times showed that it has a lot of calcium. Calcium-rich supernovae are usually associated with populations of non-massive stars exploding in remote locations, far from their host galaxies. However, in a few cases, such supernovae have early bumps or signs of circumstellar material, which is usually associated with massive stars. While we don't know exactly what kind of star made this explosion, 2022 OQM has expanded the scope of what we expect from both calcium-rich supernovae and their early time behavior. As our surveys have better and better time resolution and become more sensitive, we expect to detect more such cases and uncover the mystery of their origins. Thank you for listening.